Tonight is November the 29th, 2022, and I've been doing some work on the high voltage transformers lately. So I decided to buy a Megger, and there are a few videos out there on these very models, different colors and whatever. But I'm going to show you how accurate these things are. We're going to actually make measurements with it, and I'll show you how this thing works. It's really, I'm really quite impressed with it. For example, here's a high. Let's see, this resistor right here is a. What is it now? It's a 1.090 meg. So it's a 1.09. It's 1,090 meg. I don't know if you can read that on there or not. 1,090 meg. So it's a little bit over a gig. 1.09 gig. And I'm going to hook this thing up. And I'll put it on just a 500 volt scale. And turn it on. And measure it here. And it says, I hope you can see that, 1.09. See? 1,090 meg. It's actually darn good. And the same thing with this one. This is a 100x probe. I like the 100x probe better than the 1000x personally. But they're only made for 10 meg ohm input, so these things are really good. I've got another one just like this, except it's just a 1-to-1. But the point is and even it doesn't matter what scale it's on, the 1,000 volt scale, and it'll measure it at a, see, 1090 again. I guess you can see that, yeah. So the darn thing works. Works on all the scales. Okay, here's another thing that it does. Let me turn this thing off, because this thing, I'm going to show you some things about this contraption that could be dangerous, absolutely dangerous. Here's a meter, and if we put this on the 5,000 volt scale, this thing is 20,000 ohms per volt. I think you can see it, 20,000 ohms per volt. And if we put it on the 5,000 ohm scale, that'd be 5,000 times 20,000. So we'd put the 20 million times that, so it'd be 100 meg ohms. This one would be 100 meg ohms right here on the DC scale. And we're going to do two things at once. Well, here's one of the things kind of interesting about it is the polarity is reversed for whatever reason. The red probe is negative and the black probe is positive. I don't know what that means. I don't think it means anything. I'm sure they did it that way on purpose. Okay, I've got it on the 500 volt scale, and there it is, just short of 500 volts. I know that that's not terribly impressive right there, and it's probably a little bit less than, because this thing is loading it, but it also should measure 100 meg ohms, and it does. So we're actually measuring two things at one time. This thing is measuring the resistance of the meter, and the meter is measuring the voltage output. Now here's the thing that's kind of scary about this. I'm going to get here really quick. Let's run this thing up to 1,000, 2,000. Let's run it up to 5,000 volts. There's really 5,000 volts there. Well, there's actually 5,000, just short of 4,700 volts. This thing is actually putting out that much voltage, and it's still measuring that the meter is 100 meg ohms, which is all correct. Everything's correct. Now, okay, you go like, wow, this thing really doing almost 5,000 volts? Well, yeah, it really is. Okay, so let's turn it back off a minute. And now, let's do is put this thing in the milliamp scale. So now we've got open circuit voltage. I've already done this, so I know it's safe. Now we're going to measure short circuit current. And it doesn't matter what scale we're on. I'll even put it out up here on the 5,000 volt scale. It's completely short. It's 1 milliamp. See, this is a 10 milliamp scale right here. So it's measuring just a little over a milliamp. So open circuit voltage is whatever these scales say, and the short circuit current on every scale is 1 milliamp. So I don't think it's deadly. You know, it might bite you pretty good, but it's not deadly. Okay, now here is the part that makes me go, holy cow. I started looking at it and I said, well, could we measure and like high voltage capacitors? And there's actually quite a bit of stuff on the internet. Well, here's some of these vitamin Q, these really high. This is a 0.01 at 10,000. We can measure this one. Here's a 0.05 at 5,000. We can charge these things up to 5,000 volts with this contraption. And here's the one that's terrifying. Look at this guy. 6 microfarads is 6 kV. It will charge this thing up. It doesn't take long. It doesn't charge it up instantly like it does the small ones, but it will actually charge this thing up to where this thing becomes, this thing is deadly. It has got enough charge in it. This thing is so large, it has got enough charge in it that if you're going to start charging capacitors, start testing capacitors and charging them, you better be careful. Now, if you're going to measure these small capacitors, you could get bit. Here, let's just charge one up and I'll show you. And then we're going to charge that big one up and I'll show you. It's wow. That's all I can say. And I don't see anybody on the internet putting out any warnings. Okay, let's just charge this thing. Let's go to 5,000. Let's don't dilly-dally. Okay, and let's put this guy over here on 5 kV DC. Put this on DC. We want to be able to see everything at once here as best we can. I think you can see things actually fairly well, as long as they don't wash it out from being too bright. Okay, now we're going to charge this capacitor. Okay, see the voltage over here? 4,700 volts. It shot right up there. And the 99 meg is actually, it's measuring the meter. So if we take the meter off, doing everything with one hand here, then we can measure this capacitor, and it says that it's up at I don't know if you can see it charging. I think you can see these numbers actually fairly well. See, it says it's 40 gig ohms. So we'd say that capacitor is good. It's not leaking. 44 gig ohm. It's continuing to charge 45 gig ohms. The little gig ohm, little gig thing is down in there. Okay. Okay, and this capacitor has got darn near, look at that. It's got darn near 5,000 volts across it. Over here. Now, what I'm going to do is I'm going to take the meter off, because the meter will drain it pretty quickly. And then I'm going to, I've already done this, so I know this is relatively safe. I'm going to put this one on here, and we'll take it off, and this is just from a 0.01. I'm 0.05. That's quite a snap right there. That would bite really hard from just a little capacitor charged to 5 kilovolts. Now here, I got to make sure I got all this off. I don't want to be sent through the ceiling or downright killed. We're going to take this capacitor off. We're going to short it again, because I don't want to pick it up and get bit in any way. Okay, it's shorted. Okay, now watch this. Watch when I bring this big guy over here. Let's see, I've got to back the camera off here a little bit and move up here like this. Okay. Now we're going to take this capacitor, or not capacitor, capacitor, but the meter, and we're going to click it across there. We're also going to click our meter across it so we can actually see it charge. And I'm just showing you what. Don't do this at home. I guess I'm supposed to legally say that. Yeah, right. We'll put the meter across it. Okay. Just get it untangled a little bit so I kind of know what I'm doing. Let's put it back all the way, go to 5,000. No use of dilly-dallying around. I think you can see pretty much everything. You got to be able to see all the meters at once. What you're going to end up seeing is you're going to see the charge accumulating on the capacitor on this meter. I wish that wire wasn't in the middle. That's aggravating me. Okay, 5,000 volts. There's 5 kilovolts right here on the tip of this thing. Now watch it start charging up. I think you can even see a spark when I start touching. See, look at that. Look at that little arc right there. Now look at this capacitor charging. You see the Simpson meter rising? Okay, there's 1,500 volts. There's 2,000 volts. I mean, it's taking it a long time because this is a big capacitor. But it is putting it is putting a terrifying and an absolute deadly charge on this capacitor. It's up to 3,500 volts. So if you start charging up capacitors like this, you are building a bomb that will kill you if you get across this thing. I've got my right hand in my pocket. I do work with high voltage enough to have some experience and good sense with it, but I don't advise anybody doing this unless you know what you're doing. You better pay attention. Don't have anybody around you, your pets or anything. We're up to 4,700 volts. I think that's about as high as it goes. I don't doubt that the machine puts out 5,000 volts, or certainly darn close to it because we can measure it. But the meter's going to load it a little bit itself, even though it's 100 megohms. Okay, now I'm going to take the probe off, and see, it's starting to bleed down very, very slowly. Can you see that? That capacitor's got a staggering charge on it. I'm going to turn the meter off. Now, I've got a big 100K resistor right here. 100,000 ohm, 160 watt resistors. See how right here? We're going to discharge it with this. I'm not going to short that out. I did that a long time ago, and that is you should not dead short high voltage capacitors like this. There's a bunch of videos on YouTube where people do all this crazy stuff for you, but I'm not going to do it for you. But watch this, okay? Let's get down here and let's see, where is this? Watch this right here. I'm going to discharge it through this 100K resistor. Get it to focus real good. Look at this. Now the point is, that's through a 100,000 ohm resistor. Now it's bled off pretty well by now. But if you got across that thing right there being charged by this little device over here that actually puts out the 500, 1,000, 2,500, 5,000 volts, and you charge this guy up right here, you have got a charge on that thing that is absolutely deadly. A capacitor of this size, 6 microfarads, that'll hold up this, handle up to 6 kV, is as deadly as a turned on power supply if you get across it. So there's a bunch of videos on YouTube about checking capacitors with these guys, and you can see what checking the smaller ones are, like these. I mean, these are very special capacitors. And so are these 10,000 volt capacitors. People like these things for building things like Tesla coils. 0.01 at 10,000 volts. Isn't that cool stuff? But, I mean, even a 450 microfarad, 475 microfarad, 450 volt, 100 microfarad, 450 volt capacitor could be charged with this thing to be quite serious and could actually hurt you. So you've got a charging source right here that is just downright terrifying, up to 5 kilovolts. So be very, very careful if you buy one of these and start charging capacitors. I guess that's really all I got to say. The darn thing works. I'm really quite impressed. The voltages are accurate. The resistance readings are accurate. And they're $61. You just turn them on and see the high voltage on this. This turns it. That turns the high voltage off. You can see the HV light going off right there. Like I say, there's a bunch of videos out there on these things. So this is nothing new. So you just turn it on, and you've got that voltage out there, 5 kilovolts. One milliamp dead short. So if you pick it up, it's going to probably bite you. It's also got a 750 volt AC, like, so you can measure the 120 coming out of your wall, the 240 and that kind of stuff. 750 volt. So if you get across it on either of these scales, 500,000, 2,500, or 5,000, with a dead short current of 1 milliamp, it's probably just going to bite you pretty good, like a static discharge or something from walking across the rug. So I don't think 1 milliamp is going to be very harmful, but boy, that thing can pump a terrifying charge into a big capacitor like this. So be very careful. Hope this helps people stay safe. That's the purpose of it. Also, excuse me. Also to add that when you have capacitors like this just hanging around stored, you always want to keep them shorted, because I've actually seen this happen. I have had capacitors like this, not these particular ones that I remember, that have sat around without a shorting bar on them, and maybe they've just sat around for a year or two, who knows, some great length of time. And I said, I wonder if there's really a charge on there. And you can take a voltmeter, stick it on there. It's probably not going to be 5 kilovolts, but it could be 1 or 200 volts. I don't remember the exact number, but you can measure a little bit of voltage across them, and then you can short them, and you'll get a little spark out of them, just because these things are so darn good. And they're actually made by a company called Plastic Capacitors, Inc. Plastic capacitor, what a name, huh? But I think they make some of the best ones. Just want to say that you got to take care. See, this one's actually pretty small for its size. It's 5 microfarads at 5 kV. But nowadays, just about everybody, certainly including myself, in radio transmitters and what have you, when I need 3, 4, 5,000 volts, I series a lot of like 450 volt electrolytic capacitors with equalizing resistors across each one to bleed it down, and then some large appropriate size bleeder to bleed the whole bank down. I'll show you, I don't know, maybe I'll show you a transformer here or not. I'll have to think about it and see if it's worth testing a big transformer with this thing. Here's an actual intended use for one of these meggers. This is a 3700 volt transformer. It weighs 62 pounds. Turn this guy on. I'm going to test the insulation of the high voltage terminals down here. I think you can see them. To the case. You can actually see it. I think you'll be able to see a little tiny arc even when you yeah, see there? See a little arc? And it says that it sits up in the gig ohms. See, it says it's 3 gig ohms. I would assume that that's good course, whoa, look at that. Yeah, see, there's that 5,000 volts again. So, wow, that would, I think that would bite pretty hard. So that's what they're actually used for. And the transformer that I was floating the other day, if you watched any of my latest videos in trying to repair a transformer that had arced the case, I was trying to float the transformer up above the ground by putting it on standoffs. It ultimately didn't work, and it ended up in the trash can in the recycle bin. Oh, there's Miss Kitty Cat. See, that's why I got to turn it off. Right there. We don't want her to snip that thing.